Hey guys, welcome back. So today we are looking at 9.5. So we'll go ahead and jump right in. So for this first part here, we're looking at estimating the line of best fit. So we want to examine the scatter plot below. Imagine that you drew a straight line through the general pattern of the points, keeping as close. Keeping as close as possible to all the points with as many points above the line as below. So for number 1, predict a possible y-intercept and slope for the line you imagined. So we want to have a line through here. So for part 2, you will have the line drawn out. So if we were to draw this line that would best represent this, where approximately do you think that y-intercept would be? Probably somewhere between 101, so 1 through 104, because it's going to be up this way. So think about that line extending somewhere up that way. Should be in that range. So then for the slope, what kind of slope are we going to have? Is this going to be a positive slope? Negative slope? 0, undefined? What are we thinking? If we drew a line that best fits the data, be a negative slope. So for part 2, you're going to take and draw that line of best fits, the line that you think best represents all of that data. So you want to have it as close, as evenly placed as possible. So like it says, with as many points above as below. So try to get it to represent this data as best as possible. Alrighty? Alright, the next section. Sorry, cannot talk. So we want to match the following scatter plots with the correct correlation coefficient. So your keyword for this lesson is correlation. So correlation is your keyword for this lesson. So a correlation coefficient is basically some number that helps us understand how close together our data points are or how spread out they are. So you notice on here we have C, D, and F. They're all negative correlation coefficients. That means they're going to be going with data that has a negative, or that would have a negative slope to it if we were to draw a line for it. So that's what the negative looks like. Now, with the values, when we have a number like 0.97, so the closer to a whole number we have, that means that the data points are all fairly close together. There's not a lot of variability. They make a nice, they come together nicely to look almost like a perfect line. So that means 0.05, that's not going to be quite so close together. It's going to be more spread apart and more of a no correlation. So if we take a look at these, we are going to look at number 6. So first of all, should our correlation coefficient be positive or negative for number 6? It should be positive since we have that positive direction here. Excellent. Now, are these points fairly close together or are they very spread out? They're pretty darn close together. Excellent. They practically form a line for us. So that means we are looking for a number up here that's positive and that is close to 1. So obviously it's not going to be A. B, it's pretty close to 1. And then E, pardon me, and E is only about halfway to 1, so no. So 6 is B. All right, the next one we're going to look at is number 8. So on number 8, do we have a positive or negative correlation? What do you think? Is this going mostly in a positive direction or a negative direction as we go? Yeah, it's going in a negative direction, so it's kind of everywhere. But it is going more in a negative direction if we try and look at the trend here. So that means we're looking for a negative number from up here, and we don't want it to be very close to 1 or negative 1, I guess I should say negative 1. So looking at these, which one is the furthest from negative 1? F. So that means 8 is F. So like I said, the closer the number is to 1 or negative 1, that means it's close to being in a nice straight line. The further apart it is, or the further away it is, so the closer to 0, the more spread out the data is for that. Okay, and the last sections. This is visually comparing slopes. So follow the prompt to sketch the graph of a line on the same grid with the given characteristics. So a greater slope. So what that means is first we have to figure out what the slope is of the original line. So start from this point and go to this point. So we're going up 1 and over 1, 2, 3. So our original line has a 1/3 slope. So that means we need to take and create a slope that is more than 1/3. So easy thing that's bigger, whoops, sorry, thing would be 2/3. We could also go to a whole number. It just has to be bigger than 1/3, whatever the slope is that you decide on. So for this, we're just going to take and do a 2/3 slope instead of a 1/3 slope. So what that means is we'll just start graphing this out. It doesn't matter where we choose to start from, so I'm going to start right here, and then I'm going to go up 1, 2, and over 1, 2, 3, up 1, 2, over 1, 2, 3, down 1, 2, over 1, 2, 3, down 1, 2, over 1, 2, 3. Then we're trying to draw the line that goes between those. Hopefully I can draw it fairly straight for you guys. There we go. So when you're taking and doing these, first figure out what your original slope is to take and help you figure out the prompt. So a lesser slope. So first figure out what the slope of the line that's given is. For 10, a larger y-intercept and a lesser slope. So it's got two parts to this. Pardon me. You have to have a larger y-intercept. So that means it'll be higher up on the y-axis, but a lesser slope. So that means it should be smaller fraction. And then 11, the slope is the opposite reciprocal, which means that you're going to have perpendicular lines. Excellent. All right, so a reminder, your keyword for this lesson is correlation, which ties in with all of our scatter plots as to how those points connect to one another. Have a wonderful week and happy mathing.